the business field, right? Then we can identify some cases like this. Now with this nature, right? You can see we have two options: yes or no. Then yes or no, that means pass or fail, or success or failure, right? Then we can see that type of option, right? We have two options: the defective and good. We have two options, right? We got that example, defective and good, right? Then in that way, if we have two options, two categories, then most probably we can apply this binomial distribution. Then in addition to that, there are a number of criteria here. There is a fixed number n of identical trials. There are a number of trials, n number of trials. Here experiments are independent. Yes, for example, if you are tossing a coin, yes, then as I told earlier, then if you are tossing the same coin again, then these two are independent, right? And also, then if you are tossing a coin, we can see two options. One is head, another one is tail, right? Here again, head or tail. After tossing the coin, head or tail, again relevant criteria for here. Then trial has only success or failure, two options. Then head or tail, right? Two options here. The probability of success we can concern as P, then failure as 1 minus P or Q, right? Manufacturing plant label, now you can see example items as either defective or acceptable. Now you can see example for that. Manufacturing plant labels items as either defective or acceptable. Again, two option. Next one, you can bid for contracts. Finally, you can that mean you can win that winning process. So that mean contract, or you can get that contract or not. Then you can see two options: yes or no. Then another one, a marketing research firm receives survey response of yes, I will buy. Now, then we can see this type of response: buy or no. Then new job applicants either accept the offer or reject, right? Then we can see accept or reject, two options. Then that is the nature of this type of distributions, right? Then if you go to this probability, actually this one, yeah, here. Now instead of here, you can use the term here N C X. Here you can write the same thing: P X Q N minus X. This is the formula for getting probability under the binomial distribution, right? Then here N is here you can see number of trials. C mean combination. You know the term combination, permutation and combination. Here combinations. Then X mean here relevant number of success. Then P is success rate. That means success rate or the probability. Then X is again number of success. Q mean failure. That means 1 minus P. N is number of trials, again minus number of success. Then after applying this, you can take relevant probability for each questions. However, we need to know this extension for getting NCX. For example, if we need to take now you have 5 number of trials. Out of that, what is the chance for getting 2? Now there are number of combination. Directly you can use calculator to take this one. Otherwise, you can expand this one. Here n is 5, then 5 factorial. This means factorial. Or sometimes you are using the term factorial by using these notations too. 5 factorial. Then again NC2 mean x. X mean 2 factorial. Here instead of x. 2 5c2 no, then x is 2, n is 5, right? Then next one n minus x. N minus x means n is 5, x is 2, then 5 minus 2 factorial, right? In this way we can compute. Then factorial 5 mean this multiplications between all the numbers before the given value. Now 5 into 4 into 3 into 2 into 1. This is the factorial 5. Factorial 5. Then 5 into 4, 20 into 3, 60 into 2, 120. This is the value for factorial, factorial 5. Now you can apply factorial 5 here instead of here 120 you can apply. Here you can apply 120. Then here factorial 2 mean 2 into 2, 2 into 1, 2 into 1 mean 2, into here 5 minus 2 mean 3, factorial 3, factorial 3 mean 3 into 2 into 1, then 6. Now you can take the relevant combination, number of combination you can take. 120 divided by 12 mean 10, answer is 10. Then net answer for here is 10. Now again we can consider about the other terms in the formula, right? Therefore it is better to know about this formula. Here again NCX, right? NCX, right? NCX, again you can see the same formula, right? Then if you go to this example, now flipping a coin 4 times, then number of trials is 4. Number of trial here 4. Then your variable experiment is tossing coin 4 times. Then expected variable is x. X is number of heads. Out of 4, you can expect now how many number of heads. Now you can see this probability. You can provide answers based on the probability, right? Here n is 4. Success means number of heads. What is the chance for getting a head? Yes, 50% chance. That means 0.5. P, if it is 0.5, P 0.5, then Q should be the same, 0.5. Then chance for getting number of heads, you can see, you can expect 0 heads, 1 head, 2, up to 4 times you can take 4 heads maximum of, right? Then okay. Now to identify this binomial distribution, to understand this binomial distribution, we can use this example. This is very good example. Privacy is concern for many users of internet. One survey revealed that 59% of internet users are somewhat concerned about the confidentiality of their email, right? Then 59% concerned, that means 41% they are not concerned about that, right? Then again we have 2 options, concern, not concern, right? Then what is the question here? Based on this information, what is the probability that of the random sample of 10 internet users, right? Users 6 are concerned about the privacy of their email, right? Again we do the same thing. Now first of all we need to read this type of case. Now we have to identify the relevant probability. P is 59. 59 means 0.59. 0.59, right? Then Q is, yes, Q is 1 minus P. 1 minus P means 1 minus 0.59. Then Q is, you can write as Q is 0.41. 0.41, right? 0.41. Then we know that P as well as Q. Next one, give a number of trials. N is 10. N is 10. Now, X based on the question. In this case, X is, yes, 6 are concerned about the privacy of their email. Then, in this case, X is 6. Now, if you need to provide answer for this question, first question, then your formula should be arranged here. Probability of X exactly, yes, 6 are concerned. Exactly 6, right? 6 are concerned. Then if you convert that formula, N is 10, NC, X is 6. X, NCX, P mean 0.59, 0.59 power 6, X is 6, 0.41, Q is 0.41 power N minus X, N is 10 minus X is 6, X is 6. Then if you go to the next side, you can see that answer. Yes, you can see N is 10, P is 0.59, then Q is 0.41. This is the given formula for applying a binomial distribution, right? Now we can apply this 10C6, 0.596, 0.41, 10 minus 6, right? Then you can take direct answer from your calculator, 10C6, right? This answer should be 210, 210, right? 210. Then further you can solve this one, this one, and also 10 minus 6 means 4, no? Point. Then ultimately you can see 25% chance or the probability. 25% chance of probability, right? This is called, yes. Then after computing this in this type of calculation, probability calculations, then statistical application, we must interpret them. Then after computing this one, actually we analyze up to this point. Then after that, we have to interpret our results, right? Then actually analysis is, that means computation is useless without interpreting them. Then our main task is to interpret them. Then how to interpret them? There is a 25% chance or the probability, chance means probability, right? There is 25% probability that exactly 6 of the 10 internet users are concerned about their privacy of email, right? That is the way of providing complete, that means interpretation, right? Interpretation. Is it clear? Right? Now, first task is to identify this formula. X equal, now question mark here. Then, as per the question number 1, we have to apply 6. Right? Then, NCX, N is the total number of trials. Trials is 10. Then, here, as per the question number 1, X is equal to 6. Now, instead of X, we have to apply 6. Here also 6. Here also 6. Right? Instead of P, we have to apply 0.59. Instead of Q, we have to apply 0.41. Right? N is, yes, N is 10. Here also N is 10. Then after applying them, you can identify the relevant probability. Right? Then if you go to the question number 2, what is the question number 2? Yes. At most 3 are concerned about the privacy of their email. Out of 10,